So today, this is an addendum video to the mainboard video that was released on Sunday. When I went to go get the boards manufactured by JLCPCB, I found because of the unusual shape of the board and a few other issues, it was going to cost quite a bit to get the boards made. So I ended up having to basically make a few changes to allow me to get it produced easily and without any additional cost to myself. And I'll basically go over what those changes are. As you can see here, the board is now rectangular and a little bit more compact than what, and also a lot of this empty area here has now been filled in. So the 12 volt AC, 12 volt DC goes here now. I moved it from over here being 12 volt AC, and this basically goes in, provides the necessary 12 volts to what's required for the various zones and user outputs, but also goes into the 5 volt regulator here and provides the 5 volts to run all the digital circuitry over here. This itself hasn't changed. I had to move some wires out of pads and put them separately because of design rule limitations with KiCad and more or less what JLCPCB can produce. And that's more or less the changes that's been made to the main board. I've just basically moved the regulator from over here to over here, and that's just a 5 volt regulator for the 5 volt electronics. And now it's actually fed with 12 volts from a 12 volt power supply. So here's the schematics for the power supply. Essentially, it's the 12 volt regulator been shifted off the main board into its own separate power board. So I've got AC input here through rectification, and then through the 12 volt regulator here, and then I've got two 12 volt headers providing 12 volts. So you've got 12 volts to feed, say, one of the boards, and if there's a zone expander or other expansion device, it can be fed 12 volts from another header. This is more or less to basically keep it that you don't have to have too many cables paralleled up, as is a main issue in a lot of security panels. But it's a simple board. It basically shifts the 12 volt regulation and the unregulated input onto a separate power board, and allows for the 12 volts to be provided and easily distributed to other devices within the panel. So here's the PCB for the power supply. As you can see, it's a much smaller board. This board is significantly cheaper to produce because it's only single-sided. Well, technically double, but that's only with the 3-hole components. But it's technically a single-sided board with all the components on one side. Obviously, we've got our bridge rectifier here, our filtering caps for the unregulated 12 volt power, and of course the 12 volt regulator here, diode, and capacitor inductor filter to provide the clean output 12 volt DC at approximately 3 amps, which is what the regulator can provide. I am looking at in the future to have a different 12 volt supply. Reasoning being is I want to try and see if I can use more off-the-shelf components to produce my own switch mode type power supply, so that I'm not stuck to specific ICs that do the job. This will be addressed in another addendum video down the track, but in the meantime, the next video will be out Sunday next week, where I will go over the keypad design, which I'm currently working on, and this will allow the security system to be programmed from the main board. And then after that, I'll go over a zone expander, then a relay expander, and hopefully by the time the relay expander video is out, I should have all the PCBs from JLC PCB, and I can start to construct the boards and show their assembly and function. I'll see you then.